All right, let's get into it. Today, we're going to crack the code on a subject that, believe it or not, shapes pretty much everything around us: geometry. So let's dive in and see if we can unlock its secrets together. You ever look at a geometry problem and it just looks like a secret code? All those weird symbols and lines? Yeah, you're not alone. It can totally feel like you're trying to read a foreign language that's meant for somebody else. But what if I told you that in just the next few minutes, we're going to hand you the key to that code? That's the plan. We're going to make this whole language of geometry simple, clear, and, yeah, actually pretty useful. Okay, so first things first, every language needs an alphabet, right? Well, geometry is no different. We're going to start with the absolute basics, the letters that form the foundation for everything else we're about to build. And it all starts right here, with a point. Seriously, it's that simple. Just think of it like a single, exact location in space. It has no size, no real dimension. It's just a spot, kind of like putting a pin on a map. And we usually just label it with a capital letter, like point P. Okay, now imagine you string a bunch of those points together in a perfectly straight path. What do you get? A line. But here's the key part. See those arrows on the end? That's super important. It means a real geometric line goes on forever in both directions. No beginning, no end.
So a line goes on forever. But what if you don't want it to go on forever? What if you just want a piece of it? Well, that's called a segment. It's got two clear endpoints, which means you can actually measure it. Notice, no arrows. It starts at point A and it ends at point B. Done.
All right, this next one clears up something that trips a lot of people up. On the left, you've got congruent. Think of it as identical twins. Exactly the same shape, exactly the same size. Then on the right, you've got similar. They've got the same shape for sure, but one can be a zoomed in or zoomed out version of the other. Okay, so we've got our alphabet down. Now let's see how those letters form the nouns of our language. Shapes. These are the things we're going to be talking about. And you guessed it, they have their own set of rules. And when it comes to shapes, there are a couple of superstars you really want to know, these special right triangles. Because their angles are so specific, their side lengths follow a predictable pattern. They're like these amazing shortcuts for solving problems. Which, by the way, leads us to our next big tool. Yup, speaking of shortcuts for right triangles, I bet you've heard this chant before. SOHCHTOA. It sounds kind of like a magic spell, but it's actually just a super clever way to remember the three basic trig ratios. So how's it work? Simple. SOH just means sine is the opposite side divided by the hypotenuse. CAH tells you cosine is the adjacent side over the hypotenuse, and TOA means tangent is the opposite over the adjacent. That's it. This little tool is your key to finding missing sides and angles in pretty much any right triangle. All right, we've got our nouns, the shapes. Now it's time to learn the verbs. These are the action words of geometry, the things you can do to the shapes. And that action has a name, a transformation. It's just a fancy word for moving a shape around. The four big ones are translating, that's just sliding it, reflecting, flipping it like a mirror, rotating, turning it, and dilating, which is just resizing it, making it bigger or smaller. And here's the cool part, you can stack these transformations. You don't have to do just one. You can start with a point, say x, y, and first you rotate it 90 degrees. Then you take that new point and reflect it across the x-axis. It's like giving a shape a two-step command. Think of this table as your ultimate cheat sheet for moving shapes on a grid. Every single one of those verbs we talked about has a specific rule that tells you exactly what to do to the x and y coordinates. It takes all the guesswork out of it. It's a clear, predictable set of instructions. Okay, let's recap. We've got our alphabet, the points and lines. We've got our nouns, the shapes. And we've got our verbs, the transformations. Now it's time to put it all together and start making some sentences. And that, my friends, is where coordinate geometry comes into play. And this right here, this is your essential toolkit. With just these three formulas, you can figure out almost anything about a shape on a grid. You want to know how steep a line is? Use the slope formula. Need to know how long a segment is? That's the distance formula. Want to find the dead center of a line? Midpoint formula. These are the tools that let you actually describe and, prove things about your shapes. So here's the most important takeaway from all of this. This language we've been learning, it's not just for school. It's not stuck in a textbook. It's being spoken all around us every single day in the real world. I mean, think about it. It's the language architects use to design buildings that don't fall down. It's what video game developers use to build the virtual worlds you play in. It's the engine running computer graphics, how we plan missions to space, and so much more. Seriously, if you understand geometry, you understand how our modern world is put together. So, you have the key now. You've got the alphabet, the nouns, the verbs. You're not just looking at a secret code anymore. You can actually speak the language of shape and space. So the only question left is, now that you're fluent, what are you going to build? What will you create or describe?